This video will explain how to convert polar and rectangular equations. Please be sure that you have watched how to graph polar equations so you have some familiarity with what the equation should look like. Alright, to begin, we need to know these basic trig definitions. Cosine theta is x over r, so x equals r cosine theta. Sine of theta is y over r, so y equals r sine theta. Using the x, y's, and r's with the Pythagorean theorem, we would get r squared equals x squared plus y squared, and tangent theta is y over x. Now using these, we can convert our equations. I've got those four definitions above, and we're going to convert these four examples that are in rectangular form to polar form. To begin with the rectangular equation y equals -5, that would be a horizontal line that is 5 units below the x-axis. Let's see what it looks like in polar form. From our definition above, I see that y can replace r sine theta. So instead of y, let's change it and substitute with r sine theta. Now, r sine theta equals -5, and typically in polar form we want to see the equations r equals. To do this, we'll divide both sides by sine of theta. I would get r equals now -5 over sine of theta. Thinking back to my experience with trig, I know that 1 over sine is really cosecant. So r equals -5 cosecant theta. The second example, x squared plus y squared equals 25, well, that would be a circle in rectangular form, centered at the origin with a radius of 5. Let's see what it looks like in polar form. Above, I see that x squared plus y squared can be replaced with r squared. So let's start with that substitution. In polar form, we typically want to see r by itself, and we can do that by square rooting both sides. The square root of r squared is r, and the square root of 25 is 5. r equals 5 is the polar form for a circle centered about the origin with a radius of 5. Now 3y equals -3x is a linear function in rectangular form, but typically we want to see y by itself. So let's start by dividing to get y by itself. And if we divide both sides by 3, we would get y equals -x. In rectangular form, I see this as a diagonal line with a slope of -1 and a y-intercept of 0, 0. Let's see what it looks like in polar form. Now we could go about this problem a couple different ways. We could start by substituting r sine theta for y, and then r cosine theta for x, and then try to group the sines and cosines together to change it into tangent, but I think that's going to be a harder way to do it. So instead, I see the definition of tangent up top on the right. Tangent of theta equals y over x. Well, let's get y over x by dividing both sides by x. I can then replace y over x with tangent, and I get tangent theta equals -1. Stop and think about the unit circle. Where is the tangent going to be -1? Well, it's up and to the left or down and to the right. But where does it happen? It's where the x and y values are opposites. So that would be 3 pi over 4 up and to the left, or 7 pi over 4 down and to the right. So in polar form, the equation is going to be theta equals 3 pi over 4. That's the definition of that diagonal line. Or we could also call it 7 pi over 4 is equal to theta. Now, 3 pi over 4 is up and to the left when you graph, but if r is negative, it means you go the other direction, which will catch the 7 pi over 4 piece. So really, it could be either one of these. Now, in the last example here, y equals √3x. Y is already by itself, so we can see this is a linear function with a slope of √3 and a y-intercept of 0, 0. What's it going to look like in polar form? Well, again, we're going to y over x if we can get it to y over x, we can change it to tangent. So we'll start by dividing both sides by x. Y over x can become tangent of theta, and now it's tangent theta equals √3. Where's tangent going to be equal to √3? Well, it's going to be in quadrants 1 and 3, but y over x is a positive √3, which means it's more up than it is over. It's greater than 1. Where you're more up than you are over in quadrant 1 is going to be pi over 3, or 4 pi over 3 down in quadrant 3. On a polar graph, that would look like that. Well, that's how we're going to describe the angles to describe the polar equation. Either theta is pi over 3, using the quadrant 1 angle, or it's 4 pi over 3 using the quadrant 3 angle. Either one of these is going to work, again, because of that negative radius just means go the other direction. So you could say pi over 3 catches both sides of that, it gets the entire diagonal line. Alright, now let's go some examples going the other way. Let's start with some that are in polar form and change them to rectangular form. In polar form, r equals negative 6 cosine theta is going to be the equation of a circle where the right side hits the origin, but it's the left side that goes out 6 units. Because it's negative 6 cosine, it's being stretched to the x side to the left because it's negative 6. So circle opening to 6 to the left. Well, let's see what it looks like when we convert it to rectangular form. Well, this cosine theta almost looks like r cosine theta, but it's not quite. It doesn't have the r over here. So to get it, I'm going to have to multiply both sides of the equation by r so I can get r cosine theta. If we multiply the left side by r times r, that becomes r squared, and negative 6 cosine theta times r becomes negative 6 r cosine theta. Now we can do two substitutions. I can replace the r squared with x squared plus y squared, and I can replace the r cosine theta with x. Now thinking back to the conic sections chapter, I'll need to gather all the x's to the left so that I can complete the square here. If I move the 6x over, I'd get x squared plus 6x plus the y squared equals 0. To complete the square, we get the quantity x squared plus 6x. Half of 6 is 3, so plus 3 squared, plus y squared. And then to balance the equation, if we've added 3 squared, we need to add 3 squared to the other side, 3 squared being 9. This becomes the equation quantity x plus 3 squared plus y squared equals 9. This is a circle in rectangular form, centered at negative 3, 0, with a radius of 3. It's still going to be a circle, it's still going to be to the left of the origin, and it's still going to have that radius of 3, which means if it's centered to the left at negative 3 and 3 more units over, the furthest it will ever go is the negative 6 to the left, which is why we see r equals negative 6 cosine theta. Now the next example says r equals 12 sine theta. That means it's again going to be a circle. Because it's sine, it'll go up to a maximum of 12 units. Let's see what it looks like in rectangular form. This 12 sine theta doesn't have the r. So to get r, we're going to multiply both sides of the equation by r. R times r becomes r squared. 12 sine theta times r becomes 12r sine theta. Now let's substitute again, but instead of using x, r sine theta is y. We'll move the 12y to the other side, and now we can complete the square. We would get x squared plus the quantity y squared minus 12y. Half of negative 12 is negative 6, so plus the quantity negative 6 squared equals, and then to balance, negative 6 quantity squared is 36. This becomes the equation x squared plus the quantity y minus 6 squared equals 36. This circle is centered at 0, 6, which means it's above the origin, and has a radius of 6, which means it goes 6 units above that, which means its maximum height would be 12, and it's vertical, which is why the polar form is sine. So we can see how these two types of equations tie together. All right, our last example. Here we've got cosines and sines all in one equation. But we can notice that neither one of them has the r with it. So to get the r with the cosine and r with the sine, we're going to multiply each of the three pieces with r. So r times r is r squared. 2 cosine theta times r becomes 2r cosine theta. And negative 6 sine theta becomes negative 6 r sine theta once we multiply by r. Now we can do three substitutions. R squared becomes x squared plus y squared. 2r cosine theta becomes 2x. Minus 6r sine theta becomes minus 6y. We'll move both the 2x and the 6y to the other side so we can start completing the square. Grouping, we would get x squared minus 2x. Half of negative 2 is negative 1, so plus quantity negative 1 squared. Plus the quantity y squared plus 6y. Half of 6 is 3, so plus 3 squared. And then we're going to balance the equation. 1 squared is 1, and 3 squared is 9. This becomes the equation quantity x minus 1 squared plus quantity y plus 3 squared equals 10. This circle is going to be centered at 1, negative 3, and have a radius of root 10. All right, thank you for watching the video, and hopefully that helps how to convert your equations from rectangular and polar forms.